Okay, so today we are going to take a look at some Windows programming here. And we're going to start in the emulator and then move to actual hardware later. So I've got my Windows 3 emulator up here. It's a generic AT386 emulator. Windows 3 programming is actually pretty close to modern WinAPI. You can actually get down into the WinAPI C level programming, not C++, but actual C. Pretty similar. Maybe at the end of this we'll see how much modifications our code needs to run on a modern Windows PC. But anyway, we will get started here by opening up Notepad to start writing our C file. So, start with the C file. Of course, the first thing we need is spell correctly. Windows header, and we'll make this a little calculator program. So we'll just do so that'll do it for our includes. That's about all we need really. We'll define some constants. We'll have a constant for the edit control for our result display. Actually, we'll probably make that a label control. Or we can make an edit control. Let's make it a label for now. That's just a convention to start at 101. You can really call it whatever you want. And we'll have our initial button control. Okay, so, and then what I'm going to do with this is going to be the ID of the first button, and then like button, so that might be like button 0, and then button for 1 would be 103, and then so on. The nice thing about this stuff is you don't actually have to declare a constant for every button, because when this gets called back, it just has an ID, so I can create these buttons in a for loop, and just create an ID based on this plus whatever iteration of the loop I'm in, and it will send that back. So if, for example, if I create button 0 with button IDB init, that'll have ID 102. If I create button 1 with IDB init plus 1, that'll have ID 103. And then in my callback routine, I can just say sum equals sum plus whatever my return value was, which would be a W program, minus IDB init. I don't have to declare one for each button. I will, however, declare one for clear, because that would be beneficial. Actually, what I should do. There we go. So that way this will be the ID for the clear button, and then this will be the ID for I thought this out better. This should actually sort this out. Now, if I thought about this beforehand, what I would have done is done that first, because now I realize I need to make IDs for the function buttons as well. There we go. So like this might be the ID for add, then ID for subtract would be this plus 1, and so on. Well, I have to come back and change this when I finally work out what I want to do, but this is the way I program. I always do everything on the fly. It usually works out. Okay, so the next thing that we need is our main routine. And in Windows programming, it's not actually a main routine. The entry point is WinMain. So we will call this, which is not. Pascal. This means that it's called with the Pascal calling convention, which has a different way of passing the parameters on the stack than the the Windows calling, or not the Windows, then the C calling convention. And parameters to this procedure are the handle to the instance, the current instance, the handle to the previous instance if there are any. So if there is an instance of your program already open, Windows will pass you the handle to that instance in this parameter. This is the a pointer to a string for the command line. So if someone enters the command line when executing your program, that will get passed in that parameter. And this is the state of your window when it launches, command show. So this will be a parameter whether your program should launch maximized, minimized, or just default window size. So our handle type. This is not the regular way you declare parameter types in C, but this is the way MSC compiler likes them. I think this is MSC version 6. The 5 or 6 I think I'm using on this machine, this emulator anyway. So those are handles, and one pointer to a string. And the last one is int. Okay, so we have to, the first thing we have to do here is register our window class. So let's declare some parameter or some variables we will use later. This is for message passing in the callback routine. And a handle to our window when we create it. And we need a window class. So this window class, type properly. This window class is how we define what we want our window to be, basically. So we set up some parameters of the window class, and then that will define icon, background, different stuff like that for the window. Now in this version of Windows you can only register the window class once, so here we have to check and see if it's already registered, and if it is, then we will not register it again. And the reason how we will know if it's already been registered is if there is a previous instance. So if this previous instance exists, then that previous instance would have already registered the class and we don't have to register it again. But if that previous instance does not exist, then we do have to register. So here we will set up some data for the class. So let's set... Okay, so we'll do the icon later. We'll worry about that later. So we're not going to set an icon right now. We will set that we have no menu. So if you had a menu bar, like this menu bar up here, if you had a menu bar like that, you would pass the name of it in this parameter, the LPSC menu name. And you would have to then define that menu in a resource file, which we will get to when we're done with this. Where we can set a class name. And this class name is what we will invoke our window with. So when we create the window, we will use this class name to create a window of this class. So let's see what else. Shouldn't have to define a background, that should default to white. We need to set an instance. see what else we'll set. We'll set the redraw style. And we'll also set the Windows callback function. So when something happens to our window, since this is not object oriented, when something happens to our window, the only way we know about it is through the callback function. So Windows will call us when something happens to the window. In order for that to happen, we have to tell it what function to call, what our callback function is. And then the prototype for this function will list in the header file. Okay. So now now that we have all these parameters set up, we can now register the class. If we fail to register, you want to quit. Let's just clean up our memory. Okay, so now that we have our class set up, we can now create a window using that class. And here we pass the name of the class, so we call the class name CalcDemo. So down here we want to create a window with class CalcDemo. And that will use this class when creating our window. So some other parameters that we're going to pass here, we pass the calc name. We also have to pass a name for the window, so we'll just call this, which is the name that will appear in the title bar up here. We want the window style. So the window style, we can either use the two basic window styles are tiled and overlapped. Tiled, I think, is a holdover from Windows 1, where everything was a tiled window. Overlapped window is a window that can be on top of other windows, so that's what we're going to choose. For an overlapped window, we'll use the default. These parameters will be the X and Y location. We'll just use the default X and Y location of our window. We don't care where on the screen it comes up. If you wanted to, you could specify number of parameters for each of these as a location, X and Y location of where on the screen your window will, the top left corner of your window will appear when you open it, if you feel the need to do that. Let's do, so for height and width, let's see, for width we'll do 300, and for height let's do 400. We can come back and change these if we find out that's insufficient. For our parent window, we have no parent, so we just pass null for that. We have no menu, so we pass null for the menu as well. We need an instance handle, so pass a handle to the current instance. And we have no extra data, so we'll just pass null for there. So that creates our window. And now we can show our window. We're using the show window command, so we'll show window. And then we also pass this parameter, which was passed to us up here. this parameter is the state of our window, whether to be minimized, maximized, or whatever. So we also pass that on to show window to dictate how our window appears as specified. So now that we've shown our window, we can get messages. So what this will do is this will take messages from the message queue and pass them on to our callback function. So we declared this message parameter up here, this message variable rather, this message up here. So we're going to get a message from the message queue. And then we are going to send that message to our callback function. And then this loop will run until we post the quit message, at which point we'll exit the loop. And we'll just return whatever exit message that we had. Okay, so that is our main function basically. That takes the place of like your int main. So that was our entry point into the Windows program. And now we need to write our callback function to handle messages that this receives from Windows for our program to process. Okay, so for our main window callback function, this is also a Pascal. And this takes a handle to a window, which is the window that the message was passed for. It takes a message, and it takes two parameters, a word parameter and a long parameter. And all messages that our program, all events that happen in Windows are passed to our program via this callback function for us to process. Some of these, the variable types, might seem strange to you. These are Windows types. Most things in capital letters like this are Windows types. So Word, while Word may be a valid C type as well, this capital version of Word is a Windows type, which we get from Windows.h. So Windows.h includes all the Windows types. So things like MSG, HWind, PWindow class, all Windows types. HWind is just a handle to a window. LPSTR is just a long pointer to a string. MSG is just a message type. Pretty much the only thing you use that for is the callback function. This thing down here. I've never seen it used anywhere else. Word and long are Windows types. Again, this is probably just defined as a long int or something. But since Windows defines them, we'll use them. So now, what we do in here is we have a switch that listens to this message parameter. And based on what this message parameter is, these other parameters take on different meanings. So, and also, so all windows have this callback function. When you declare an edit control, that edit control also has a callback function. So if you want to change the text of that edit control, you have to send it a message through its callback function, telling it to change the text using this. The message for that would be WM set text. And then these two parameters dictate how to handle that. So when you send an edit control the message WM set text, you pass nothing here, and you pass a pointer to the string that you want here. and that will force the edit control to set the text that you want it to set. So we have our switch. So the first case that we'll do is when the window is created, we want to create all of our controls for the window. So in here, let's see, let's declare some types first. So let's declare so that'll be a button for the clear button. Okay, so we'll have a button for clear, basic button for a function, and button for no. So now, there we go, create, let's create. So this is how you add controls to your window. So a button is actually another type of window, and it has class button. Let's call this. And let's. So after this, I believe we add. I just want to check to make sure I'm using the right function for it. That should be a valid type. We'll find out in a minute. It's invisible. Okay, so then we should have our X and Y. Let's just create this at, let's see, where should we create this? Always underneath. Add numbers for this, always have to rearrange everything. It's hard to visualize in your head where everything's going to go. If we want to have our edit control across the top, this should actually be a little bit lower than that. So let's make this let's make it 40. Let's see what else we have to do. Let's recast our window type, XY, width, height. Scroll bars in this version, the windows are very useful. Okay, so let's give it a height. Width of 40, height of 15. So the next thing was parent, so our parent is our window. And the next thing is the menu, and this is where we pass the ID. So what do we call that ID again? So I remember stuff. We call it IDB clear. Okay, that's what we want to pass here. And I think after this we just pass nothing. We have to pass the instance. So let's see if this works in this version. I can't remember whether it does or not. This is how you do it in modern versions of Windows. If this works in this version. If not, we'll have to save the H instance. We'll have to save the H instance in the WinMain procedure, and then say that in global variable, and then use it down here. Okay, so that should create our clear button. We also have to create. And so we have to create our other buttons. We also have to create an edit control. So let's add the edit control. So we gotta define ID for the edit control. Label ID element. Okay. Okay, so let's create that. This still has the edit class. Okay, so I was mistaken. This is actually a static control we want here. Just get this. And so we want to have this above the above the clear button here, so we'll put this at 5. Where's X5? So 5, 10. We'll make this 50. Actually, we'll make that very small. Nice big window. We're going over 300, so let's make this 250. We'll see how that looks. And the height will make it 15 as well. So then, so we're passing our window. We're passing the control ID. There's the menu parameter, since these controls actually cannot possibly have a menu. That's why we pass the control ID through the menu parameter. And the rest of it should just be nothing. Oh, the instance, of course. Okay, so now we have our result and our clear button. So let's see, we now need to create our other buttons. So let's do this. Tell how well I play on this on Hamilton. I'm just going to create all of our function buttons right here in this loop. That was probably not a good idea because I'm not going to have the right text on them. So let's not create them in this loop. So this would be good if you have sequential button text labels. But I'm going to have to put plus here, and I'm pretty sure minus is not the next ASCII character, so I can't do this the way I was originally thinking of. Although I still can do it for the number keys, because those will be sequential ASCII characters. So we're going to have plus. Let's see, where do we want to make these buttons? So let's see. Okay, so this is at, so this is across the top, that's fine. This is at 40, 10. Wait a minute, I can't be right. This is the X, so this should be at 10. This should be at 40. So if we want to create these going down the left side of the window, we can put this at 10, 16. And then the width and the height, we can just make this, we'll make it 20 by 20. to make it 15 by 15, which will be... Of course, once we actually compile this, we'll have to see how this looks and adjust accordingly. This is going to be the same, or it's going to have to change the location and the character, but I'm really not really shortcut key to this version. Okay, so now we're just going to change some of these. Go through and change the Y locations. So this will be 80, 100, and 110. Okay. And I think what I'm going to do is see how this looks first. Before I go ahead and create the number keys, I'm going to compile this and see how this looks, make sure this looks okay, and then figure out how I'm going to fit the number keys in. It's going to help if I actually have something here. Now we shouldn't have to save these, so I can overwrite this. What these are is these are the handles to the window, so kind of think of these as a fancy pointer. Now, since I'm only going to use these buttons for listening to when they get clicked, I don't actually have to save these pointers. I only have to save these, I only have to save the handles if I want to send messages to the window. So for example, if I want to make the button disabled, or if I want to change the text, or if I want to, I don't know if you can move it. I think you can. I don't know. I never looked into that. But if I want to change this button in some way, I need to save this handle. But since I shouldn't have to do that, I don't have to save these handles for anything. The same thing with the number buttons. Since I shouldn't be making any changes to those buttons while my program is running, I don't have to save these handles for anything. The only important thing that I do have to have unique is the button ID, and that's what's going to get passed to this procedure when Windows calls this function. So I can overwrite these with no fear because I should never have to use them. Okay, so we'll come back to this once we see how this looks, and then we'll do the number keys. I'm sure I'll have to rearrange some of this stuff too. Okay, so for now we're just going to have a default case. This is the default Windows processing function, so if I don't want to implement any messages, I don't have to. Windows has a default message handler that, or default callback function that I can use if I don't want to implement the messages. The only problem is it doesn't do anything interesting. So this default window proc actually implements the WM create message, but it doesn't do any of this stuff. It just creates a blank window with nothing on it. So if I want to do something above and beyond of what def window proc does, then I have to implement these message handlers myself. But for right now, I'm just going to use this for every other message, since I don't care what happens when any other message comes. I'm not going to worry about that yet. Although I think I am going to do WM destroy. So this is when someone closes the window. I don't think that the default window procedure exits the program. So when someone closes the window, I don't think that the default window procedure actually kills the program and exits the program. So you can close the window and then the program is still running with no way to get out of it. So implementing the WM destroy message and putting this there will quit the program. So what this does is this puts a message onto the queue so that up here in this loop, when it gets that message, it exits out of this loop and returns and exits the program.